About 3 years ago, I was part of a team that made a big discovery that shook the world of science, a controversial discovery in planetary science. Our atmosphere is not just oxygen, but believe it or not, I actually uncovered this factoid that every gas in our Earth's atmosphere that is there to the part per trillion level, with the exception of the noble gases, which are inert. So every gas that's there to the part per trillion level is actually produced by life. Its main source is usually not life, but it's also produced by life. So even ozone, for example, is produced inside some cells. So this sort of motivated me to make this giant list. It's kind of neither here nor there, but went through all the gases, have a giant list, have this kind of side research project we just call chemoinformatics. And this illustration is just showing you like a sea of molecules we call chemical space, in sort of a similar way that people use for drug discovery, but we're using it for thinking about gases that might be made by life on other planets. And this picture just captures them being sorted by our computer algorithm, which here is shown by this shaker filter, going into 3 streams, 2 of them that we hope might be relevant for life, and some that, for some reason, life just seems to avoid. Anyway, long story short, we certainly didn't need all of this machinery to realize that phosphine is a very intriguing biosignature gas, but it popped out in many different ways through this framework. Now, phosphorus is an essential element for all life on Earth. But here on Earth, as you know, we have very little hydrogen floating around. Well, none, really. And we have a lot of oxygen. So phosphorus is typically here as phosphates, phosphorus attached to oxygen atoms, whereas phosphine is phosphorus attached to hydrogen atoms. It's highly thermodynamically disfavored. You're not going to find phosphine getting spontaneously made here. And it's amazing, but on Earth, phosphine is only associated with life. That's bacteria cultured in the lab, bacteria in wetlands, like in oxygen-free environments, in animal guts, in Antarctica over penguin colonies, penguin poop, lots of phosphine. So we came up with this idea that phosphine could be a great biosignature gas, because on any rocky planet, it's very, without hydrogen, it's just unlikely that there could be phosphine. Meanwhile, what happened around that same time, pretty surprisingly actually, across the globe, Professor Jane Greaves was also thinking of phosphine as a sign of life, a biosignature gas. It's just really unusual for astronomers to do this. But one of the great things that certainly at MIT we excel on, in other places not so much, it's really taking risks and really stepping outside the box.